Hello and very welcome to our tutorial sessions on the digital logic design using Verilog. And in our previous module, we saw a very first example of Verilog coding. So it's a hardware description language that we can use to describe a digital logic, and thereby we can create an integrated circuits and send it to manufacturing. So we had a similar logic circuit in our previous model, except the difference here now we have another additional logic gate. So this is a NOT gate or an inverter. This is a OR gate followed by the bubble here. So that makes it NOR logic, NOR gate. And this is an AND gate of it, this circuit. These are the A, B, C, the inputs to the circuit. And here is a Y, that is an output to the circuit. Here is an internal connection. If we want to seek the output at this node, we call it label D. So if we ask you to write the Boolean expressions for the given input for this circuit, you can see that in the intermediate point at logic D, you have A input. So here it comes A bar, that is the inverted version of logic A, and A bar, and here comes the input B. So there is a ORing of A bar and B, and then again inverter makes it the NOR operation. So here is how you write the D equals to A bar or B and take a bar of it. So that's the first one. Then the logic at the output Y will be the AND operation of inputs D and C is coming right over here. So C and D, that is output Y, which I have written here, Y equals to C and D. However, we know that the D has an expression of this one. So instead of D, you can simply say C dot here. You need to place a dot here that signifies the AND operation, and then C and in parenthesis A bar or B and take a complement of it. So this circuit you want to implement, let's say in this in the integrated circuit form, this is how the IC looks like. Okay, obviously there'll be a millions of such gates on the circuits and the systems, but we are explaining it with very simple example. Now you are asked as an exercise to write a Verilog code to describe this hardware. So that's the hardware description language. Verilog is a hardware description language, in short, HDL. So how will you do that? So here I have explained to you in the previous module. If you are new here, you are encouraged to refer back to our previous module to start with. This is the second module on the Verilog example. So I have manually written a code that I will explain you in the moment, and you can also type the same code here. So always you see that the Verilog coding will start with the two constructs, that is the module and the end module. So in the beginning you start module, and in the end you end the module with the end module. So these two are the by default. Okay, and then give a name to your circuit. So you can call it as an example or combinational circuit. I have named it as a simple underscore circuit. So that is the underscore you can use, simple circuit. Now note the colors I have used here. So I have used the module, end module, and input output ports, wires, and the assign statements. I have used a particular color, that is red, to distinguish and tell the viewers like you that these are my Verilog constructs or keywords. Okay, and then these are the blue color indicates the syntax I am using to define the ports, define the wire, assign the statements, and all that. So we'll see that one by one. And also the parenthesis has also been used to define, between the parentheses you will have input and output ports of your circuit. So I have said you start with module and then write end module, these two keywords or that you use, and then give a name to your circuit, for example simple underscore circuit. Then write two parentheses, the opening and the closed one, and in between those parentheses, you have to tell what are your outputs of the circuit and what your inputs of the circuits are. So output here, obviously, I have only one or single output Y. So I write output is Y. And I have three input variables. So these are actually I have these are called variables. Inputs and outputs are called as variables of the circuit. So I have three inputs, three variables ABC as inputs, and one variable Y as the output. So I write input A comma B comma C. So parenthesis is already closed, and after that don't forget to give a semicolon. So that indicates the end of the statement, particular line, sentence. Then as I said, there is this internal connection. So if I want to assign some value to this point, I will use a wire. This is called as wire. In a hardware, actually, there'll be this is a wire. Oh, okay. So I will write the keyword wire and D, and again semicolon. Okay. Now I am actually, I want to express this Boolean expression D and Y in the Verilog coding. So it's basically, I'm not writing the Boolean equations as it is. However, through the Verilog coding, I will tell the the synthesis tool. So when you actually make a coding and then you simulate, then you send the code to the synthesis tool that creates your gate level netlist. So basically synthesis tools understand by this expression that what you want to implement. Accordingly, it assigns some logic gates to your circuit as per the description. So the special keyword I will use here, assign. So assign, I'm assigning to the variable D some operation. So what is that operation? Look at this now. This special symbol is indicating the not operation. Then the two standing lines indicates the OR operation, and these two symbols that you can find on your computer keypad or keyboard, this signifies your AND operation. So if you are not clearly able to see here, you can actually have a look at here. Okay, so look here, assign D. So I'm assigning to a variable D some operation. What operation I am assigning? First, I know that D is equal to A bar or B, and then take a bar of the complete expression. So first I want to implement A bar. So in the parenthesis here, I write not of A. After that, I perform OR operation. So with the not of A, I am ORing the B, and then I close the bracket. Then I close the bracket. So I have two parentheses here, these two parentheses, and again opening and closing one. So don't get mistaken here. If you miss the one parenthesis, you will, when you compile the code, you will run into an error, but that can also be solved because the tool will tell you, okay, you have some error in closing and opening the brackets, but you have to be sure. And then this final complement, I am assigning here again the not operation. Okay, next one, assign Y. So I have done the connection here. Now assign Y. Y is simple AND operation of between C and D variables. So assign here Y, that is equal to C and D. So that's how I can do it. What if, and that is what I have done here in the manually, assign D equals to this expression, which is exactly this one, and assign Y equal to C and D, which is exactly this one. What if I don't want to write two separate assign statements? Instead, I want to write a single statement assign and give assigned to the Y variable the complete operation that is happening here. So what I can do is Y equals to, I know, C and this expression. This is basically a D, what is here. So instead of D, I write this complete expression, that is A bar or B bar, and then take a complement of it. So you can see here, instead of using these two separate assign statements, I will use the one single assign statement right here. The two tilted lines indicates that is a comment section. So if I remove these two lines, so this assign will also get into the boldface letter like this, and that becomes then a command into the Verilog code. So when the code will be executed, this sentence will also be executed if you remove these two lines. Otherwise, if you execute this code, this will be treated as a comment and therefore it will be ignored. So this I have put two lines just to tell you, instead of writing two assigns separately, you can use simple one assign statement, that is y equal to c and d. And what is d? D is the same expression that I have put up here, that is, take a knot of a or it with b and then close the bracket, take again the knot, that becomes your NOR operation. Okay, and then the module and the end module as it is, you had it before, output, inputs, wire, everything is defined. So you see, this is how you have successfully written a Verilog module code with for a simple combinational circuit like this. And in this module you understood how to use the different keywords such as module, output, input, wire, assign, okay, and end module. You understood how to define input and output ports. You understood how to write the expression for the wire, and most important, the boolean operation that you wish to perform, and then accordingly implement the hardware, which is the combinational circuit using logic gates. You understood how to write the assign statements. Okay, so parentheses, you understood about not, symbol for not, symbol for or, and symbol for and here. And then you already know the end module. After this, you want to write a test bench, because test bench is another small code that provides to your main Verilog code, which is this one, the external stimulus, that is A by C, A, B, C, and accordingly it will show you then the output Y will also be receiving the corresponding output logic. Okay, so we'll understand test bench some other sessions how to do that. And once that is done, your simulation is performed, you verify the operation through the logic diagram, whether the circuit is performing as intended, and then you send that netlist to layout, and then accordingly your circuit can be sent to the foundry for manufacturing, and then this is how you get the IC. So this IC, for example, a complete microprocessor, is not a simple logic circuit as this, but the microprocessor essentially is all composed of combinational and sequential circuits, right? So we'll see that later some other topic. So stay tuned for more engaging contents and short modules, very effective tutorials and engaging tutorials like this. And till then, wish you happy learning. So understand that this I have written manually to make you understand. Here I have typed it. So basically you can simply copy paste this code into your simulator. There are a variety of free open source tools available on the internet. You search for the Verilog simulation, and you will simulate this. But just type, copy and paste this code there and click the simulation button. You will get the simulation results, and in the form of waveform or logic truth table, etc. Okay, so hope you will stay tuned for more engaging content like this. See you very soon with another interesting examples. If you like this module, share it with others for wider reach. Wish you happy learning.